Hello viewers, welcome back to Luna Learn 24. In this tutorial, we are looking at solving systems of equations by the matrix method. In solving a system of equations by the matrix method, there are three things we need. To do. One, we need to form the matrices M, U, and C, where M is the coefficient matrix, U is the unknown matrix, and C is the constant. The second step is to find the inverse of the matrix M, that's the inverse of the coefficient matrix. And the last step, we are going to pre-multiply the matrix of constants by the inverse of the coefficient matrix. So step 1, form the matrices M, U, and C. Step 2, find M inverse. And step 3, simplify U equals M inverse times C. Okay? So for example, solve the system of equations x plus y equals 3 and x minus y equals 1. So step 1, we are going to form the matrix of coefficients. This is a simple way to do it. In equation 1, it starts with x. We have x and y equals 3. So we have how many x? 1x. How many y? 1y. So we have 1, 1. Okay? So the value of 1x and 1y in equation 1 is equal to 3. So that's it. Then equation 2, how many x? 1. How many y? Negative 1. Now we are solving for x and y. Okay? So x and y in the second matrix now, and the constants are 3, 1. So this is how we form the matrices M, U, and C. Step 1 is complete. Step 2, we are going to find the inverse of this coefficient matrix, because this equation is now in the form MU equals C, where M is the coefficient matrix, U is the unknown, and C is the constant. So these are the values MU, C. Here we're going now to find the inverse of the matrix M, and there are two things to do in finding the inverse of a matrix. We need then a determinant, and we equally need the adjugate or the adjoint. So to find the determinant of this matrix M is going to be the product of the leading diagonal entries. So 1 times minus 1 or negative 1 minus the product of the off or the reverse diagonal entries. So minus 1 times 1. So this is the off or the reverse diagonal line. So 1 times 1. So what's this value going to give us? Watch our previous videos on adjugates of matrices and determinants of matrices. We have the videos in the same channel. So 1 times a negative 1 is negative 1 minus 1 times 1, which is 1. So negative 1 minus 1 is equal to negative 2. Then we need the adjugate of this coefficient matrix as well. The adjugate is given by, so we are going to swap the leading diagonal entries, their positions, swap. So we are going to exchange their positions, or we swap their positions. So negative 1 will come here, and this 1 will go to the position where negative 1 is. So we swap their positions. And then for the off diagonal entries, we just change their signs. Because now they are both positive, we change them to negative. If one was positive and one was negative, we will still change the signs, okay? We change the one that is positive to negative and the one that is negative to positive, okay? Good. So whatever sign is there in front of anyone, just change the sign. So now the inverse is given by 1 over the determinant, that is 1 over negative 2 times the adjugate. So 1 over negative 2 into negative 1, negative 1, negative 1, 1. So this is step 2. Step 2 is complete. Step 3, we are just going to simplify that product to find U. From step 3, our U will be equal to M inverse times C. Our M inverse is negative a half into a negative 1, negative 1, negative 1, 1 times C, a matrix of constant, or is 3, negative 1. Sorry, it's 3, 1. So we are going to simplify this matrix multiplication. So this is going to give us negative a half into negative 1 times 3. That's it. And then we have negative plus negative 1 times 1. We multiply this row by this column. So we have negative 1 times 3. You can watch the previous video, you see matrix multiplication. Negative 1 times 3 plus negative 1 times 1. So plus negative 1 times 1. Therefore, the next row here, we have negative 1 times 3 plus 1 times 1. We now simplify. That's going to give us negative a half into, so for the first part here, we have negative 4, and below, we equally have negative 2. So negative a half times negative 4 here, negative a half times negative 4 is equal to 2, and negative a half times negative 2 is 1. So, but you know that our u is equal to xy. So therefore, you have xy equals 2, and therefore x equals 2 and y equals 1. Yeah, doing it the first time might seem pretty tough. Let's take another example and another example. We have 3 examples in these tutorials, and you're going to see that this thing is pretty simple. Please don't forget to subscribe, like, to share, and to leave your comments below these videos, okay? We equally offer tutorials in statistics, calculus, and much more. You can visit us at www.linearlearn24.com. Example number 2. So here we have x plus y equals 1 and x plus 2y equals 0. Like previously, 3 steps. Form the matrices M, U, and C. Step 2, find M inverse. Step 3, simplify U equals M inverse times C. So for our coefficient matrices, you have 1, 1, 1, 2. Make sure that x comes before y in this equation. If it's not like that, you rearrange it. 1, 1, 1, 2. Okay? We are solving for x and y. The constants are 1 and 0. So now we need to find the determinant of the coefficient matrix, which is m. So that m is just going to be equal to, that m will be equal to 1 times 2 minus 1 times 1. So we have 1 times 2 minus 1 times 1. And that gives us, the result is 1. Now we find the adjoint or adjugate of m. So m will be equal to, we swap the positions of 1 and 2 leading diagonal entries, swap their positions, and we change the signs in front of these off diagonal entries. So our m inverse now will be equal to 1 over this determinant times the adjugate. And from here, we can go to step 3 to find our u. We pre-multiply this constant matrix by the inverse of m. That's going to give us 1 over 1 into 2 minus 1 minus 1, 1 into 1, 0. To simplify, we're going to have 1 divided by 1 is 1, right? So now we have 2 times 1 plus negative 1 times 0. Then we have 1 times negative 1 times 1 plus 1 times 0. So our results are 1 into 2, negative 1. Therefore, from here, our x is 2 and our y is negative 1. Simple, right? Let's take the third example. You see how easy this thing is. But don't forget, guys, that we actually offer tutorials and cover areas in calculus, statistics, and geometry. You can go to our website for the free classes and quizzes. Just go and click on login. You're not going to log in, don't bother. Or if you have to log in, they ask for anything, the password and username are there for the guest. Okay, you just use that one and log in. If you are registered, you use your registered one. Please like our videos, subscribe, and share. That is what keeps us going. It is your subscription, your shares, and your likes that keeps the channel moving. So please help us to actually build this channel to help you more tutorials. That brings us to example number 3. We have 3x plus 2y equals 13 and 5x minus 4y equals 7. So step 1, form the matrix of coefficients. Now speak, or you can be solving now, you can be talking along with me. So what will be the coefficient matrix elements or entries? 3, 2, 5, negative 4. You're right. What are we solving for? X and y. Good. What are the constants? 13, 7. That brings us the end of step 1. Step 2, what are we supposed to do? Yes, we are to look for the inverse of the coefficient matrix. And what's the first thing to get that inverse? We find the determinant of the matrix M. That's the coefficient matrix. And the determinant is going to be equal to, give me the values. Yes, 3 times negative 4 minus 5 times 2, or 2 times 5 is still okay. Good. So that's going to give us, when you simplify, what do you have? Negative 22, correct. That brings us to step 2. The second part of it, sorry, to find HM. How do we find the aggregate of the 2 by 2 matrix? We swap the leading diagonal entries and change the signs in front of the off diagonal entry. So what are the values for the leading diagonal entries? Correct, negative 4, 3. We have swapped their positions. And for the off diagonal entries, what will be the values for the signs? All right, negative 5 and negative 2 there. Perfect. How do we get the inverse now? 1 over the determinant times the aggregate, correct. And that brings us to the last step. So for the last step, we are going to be simplifying the equation M inverse times C. So we have 1 over negative 22 into negative 4, negative 2, negative 5, 3 times C, which is 13, 7. Let's simplify the matrices first before the constants outside. So we have 1 over negative 22 into, yes, negative 4 times 13 plus negative 2 times 7. Correct. Negative 4 times 13 plus negative 2 times 7. And we have negative 5 times 13 plus 3 times 7. So when we simplify that, we are going to have, yes, negative 1 over negative that into, correct. So x is 3 and y is 2. Perfect. Perfect. So thank you so much, and there is an exercise for you to do. Please, when you do this exercise, leave your comments below. Write the answers below so that we know that you are following. So the exercise is solve this equation x plus 2y equals 1 and x minus 2y equals 9. Please write your answers below and leave your comments so that we know if this video is interesting, we should make more or we should stop. Thank you so much. Don't forget to subscribe, to like, and to share. And you can equally visit our website for more. Bye bye. See you in the next video.